So hello guys, let's solve today's LeetCode daily question, which is longest nice subarray. So let us see what does the question say. You are given an array nums consisting of positive integers. We can call we call a subarray of nums nice if the bitwise AND of every pair of elements that are in different position in the subarray is equal to 0. Return the length of longest nice subarray. Okay, then have given what is a subarray. And notice that subarray of length 1 are always considered nice. So first of all, whenever you see the word subarray, the first thing that should come to your mind is sliding windows. So let us now break down what the question wants to say. Okay, so firstly, what is a subarray? A subarray is a contiguous part of any array. It can be 3, 8, 48, it can be 1, 3, it can be 48 and 10, it can be a single element like 8. But the condition is they should be contiguous in nature. Like a subarray can't be 1, 8, and 10. These are not continuous. So first thing, we know what is a subarray. And then the question is saying a subarray is nice if bitwise AND, mean this AND operation, of every pair of elements that are that are in different position in the subarray is equal to 0. Saying is the AND operation of all these different pairs 1 8 1 3 3 8, these are the only pairs possible. So AND operation of 1 and 3, 1 and 8, 3 and 8, all of these should be 0, and we have to return the maximum length subarray which can satisfy this property. So let us look at this example. 1 can be written as 0 0 1 in binary, 3 is written as 0 1 1. So now if we perform an AND operation on these, we get the answer as 0 1 1, which is not equal to 0. So 1 and 3 are not like this subarray is not a nice subarray. So we can move forward. Let us check for 3 and 8. 3 is written as 0 1 1, 8 is written as 1 0 0. Now if we perform AND operation, we will get 0 0 and 0, which satisfy the condition. So 3 and 8, currently 3 and 8 is the largest possible subarray, and its size will be 2. So we can store that to somewhere, and moving forward, currently we have 3 and 8 satisfying our answer. Let us also check for 48. Okay, so 3 was 0 1 1, t is 0 1 1, 8 can be written as something like this, and 48 will be written like 1 1 0 0 0 0. So if we perform an AND operation of these three, you can see you will get answer as 0 0 0 0 0 and 0. Again, our condition is satisfied once again. So we can extend our subarray, which is a nice subarray, to these three, and the max length of our nice subarray will be increased by to 3. Now let us check for 10. 10 can be written as uh, 0 0 1 0 1 0. Separately do AND operations of 10 with all others. We can see that 10 and 3 will be not equal to 0. 10 is written as 1 0 1 0, 3 is written as 0 0 1 1, which is not equal to 0. So this does not, 10 can't be fit in, like if we add 10 in our current maximum subarray, it will ruin our answer. So we cannot include that. So basically we cannot include 10 in our subarray, and our maximum subarray length will be 3, as it is written here. 3 and 8 uh, when ended together gives 0. 3 and 48 gives 0. 8 and 48 also gives 0. So you can actually, it is a pretty simple sliding window question. We can initiate L with 0. We can put a leftmost corner of window L at 0, and again R at 0. Then we just have to figure out conditions and 2 to 3 other things how we can store the answer. Okay, let us try to dry run our code or make up our code, okay, in our mind according to some approach. So think it in a let us start to think in a sliding window way. So let us suppose at the beginning our window is just of size 1, okay, and it is sitting as at 1. So we know that we have to, if it is said in question that it is given that if we have only single size subarray, then answer is 1. Okay, so currently our window is of size 1, and to check for possible answer we have to increase this window size, like we have to go to 3 and check if 1 and 3 gives 0 or not. So let us do that. Yeah, so let us suppose we went for 3 and we are checking if 1, which is 0 1, and 3 satisfy our condition or not, and we can see that they don't satisfy our condition. What we'll do is shift our this window to right side. Okay, so now our window is looking something like this. Now again, checking for 3 and 8, we'll try to slide our window to the right, and we'll check for 3 and 8 if it is possible to make a subarray out of them. And we can see that if we AND both, if we do an AND operation of 3 and 8, we get 0 0 0. So we know that these two when ANDed with each other give 0. So this is a possible answer. Now when we are including 48, we have to check that 48 ANDed with 3 and 48 ANDed with 8, both of these should give 0 answer. Otherwise, if any one of these gives a non-zero answer, we cannot consider that 48 as a part of our new summary. So uh, we have to check the new number which will be inserted should be nice with all of the other elements which are already present in our summary. So there are two ways to do that. Either you can take 48 and loop through this whole your subarray, or there is a smart way. And how can we execute this smart way? We can use OR operation. Okay, so what OR operator does is, let us take 3. 3 can be written as 0 1 0. Let us take 8, that is 1 0 0. And if we do an OR operation on them, we can see that we have combined all the zeros which were in 3 and 8. Okay, so the final answer we got was 11. This is something like addition. Okay, you can consider it like that. So when we use or operator on all these previous numbers, we are making sure that this final answer, which we got after ORing all these previous elements, contains all ones at different positions, so that we are not missing any one which has already occurred due to 3 or 8 or something, some other element. Okay, so we are what OR operation is doing, that it is taking all the ones that were at different positions due to different elements. Okay, and now instead of looping through 3 8 and whatever to check is it compatible with 48 or not, what we can do is we can directly check with this answer, this final answer, and these are going to give same result. So you have conserved some steps. Earlier you were trying to loop through some number of elements, and now you are just doing one operation instead of that. Okay, so this is a small time optimization. Okay, so now we have uh, figured out how to increase the size of our window. Okay, so currently our window size has become 3. We can store that somewhere. Now we have to figure out what will we do when we uh, when condition is not satisfied. Okay, this condition, if it breaks, then what we have to do? So now when 48 is validated, or verified that it is a part of this subarray, we have to check for 10. And what we will do is again check for 10 with 48, check 10 with 8, check 10 with 3. Okay, which will be done by not looping but this logic. Okay, so if we do if you will do AND operation of 10 with 48, 8 and 3, you will get to know that not all of these answers are 0. Okay, at least one of them is going to be non-zero. You can do that yourself. So in that case, we can't shift this window to one more to 10, or we can't increase this size to 4 because it is not a correct answer. So in that case, what we'll do is just like in other any other sliding window approach, we will shift this left window or left part to here. Hmm. So now our window will look something like this. But the part is the hard part is if we are removing this 3, we will also have to cancel out this effect of 3 which we were using in this OR operation. Okay, and to do that we are going to use XOR operation. Let's see, 3, 8, 48. When these were OR together, let us make a table. And 48 will look like this. So let us do their ORing. So the OR operation of these three looks something like this. But now when you are shifting the window to right, currently your window was of size 3, you are trying to make it compatible with 10, but uh, let us say 10 and 3 is not giving 0. So we have to remove this 3 in order to shift our window. So when we are going to remove this 3 or shift our window from here to here, we also have to remove the effect of this 3 from this answer. And how can we do that? This answer, let us take it here. When we will perform an XOR operation of this with 3, then it will give an answer like something like this. So what we can observe is that the effect of 3 from this answer is now eradicated or gone. So it was simple, but it does not come up in mind that easily. But now you know something new. So now we have got both the conditions. When your new element is compatible to be added in your answer, then what you have to do, and if your this 10 is not compatible to be added in answer, then how you will shrink the window. So now you have both the logic for shrinking and expanding the window. So let me show you the code. It is pretty simple actually. So this is how the code looks like. L and R for window. This OR answer will be storing these, which I told you, so that you don't have to loop through your current subarray. And maxi, this will store your final max answer, which is going to be the size of your subarray, maximum subarray. So we have taken a loop, and the loop will run until R reaches the end. And again, inside this loop, this while is used when for not condition, when your new number, which is going to be put in, in your subarray, when you are counting its size, when it will not satisfy the answer, then this is the condition what is going to happen. So let's see. Or is equal or XOR is equal to nums of L. Okay, means we are removing the leftmost window, the leftmost number from the or answer or the final answer which I was saying, and simply shifting L to rightmost position, right position. And then if all this is not happening, then what will happen? Or answer or equal to nums of r. This line is doing this operation. We are taking 3, 8, 48 one by one and oring it into, or we are doing or operation on them so that the answer is accumulated on all, you know, all that. Okay. And then simply we are maximizing our answer. And what is that? The size of subarray. And we can simply calculate that by using r minus l plus 1. And lastly, we are shifting r so that our loop does not, this bigger for loop, the outer while loop does not go in an infinity loop, and simply we are returning maxi. So I think it was a pretty easy question. If you if you will try run this code 1 or 2 times by yourself, you will get it more clearly. Thank you.